In this video, we're going to use the fundamental theorem of algebra to find all the roots of a polynomial. So let's just look at this big title, the fundamental theorem of algebra. All that is it's saying we're going to look at what degree function this is. So this is a fourth degree function, which means that it should have 4 roots. Okay? So what we need to do is we need to see if we can find any roots on the calculator since nothing has been given to us. There's a whole process for doing this, but I'm not going to go into that on this video. So the first thing I did is I put this equation into my y equals, then I graphed it. So I see that I should have 4 roots. I'm only seeing 2. So let's look at what these roots are. Right here, that's where x is -2, and this here is where x is 3. I can look at my table just to verify that's so. So you can see where y is 0, x is 3, and where y is 0, x is -2. So I know that I have these zeros. I'm going to write this down. I have these zeros, and my zeros are x is -2, and x is 3. So those are my zeros. But because of the fundamental theorem of algebra, I know that I'm missing 2. These zeros are real. Both of these are real because they come from the land of real. But I'm missing 2. So that means the other 2 roots must be imaginary. Okay, so the other 2 roots must be imaginary. So let's see if we can figure out what they are. To do this problem, because I'm given the zeros, I'm going to actually do synthetic division. I'm going to do it in a special way. So since I already have my zeros, I'm going to use my first 0. Let's put that here, -2. And then I'm going to put my coefficients for each of my positions. I'm going to make sure I have all of my exponents, 4, 3, 2, 1, none, which means I don't have to put in any placeholders. The coefficient for x to the 4th is 1, so I'm going to write down 1. The coefficient for negative x cubed is -1. The coefficient for x squared is 10. The coefficient for x is -16, and then we just have -96. Okay, so let's remember the process here. So what are we going to do? We first bring down that 1. Then we have -2 times 1, which is -2. Then we add -1 and -2 gives -3. -2 times -3 gives us 6. 10 plus 6 gives me 16. -2 times 16 gives me -32. -16 plus 32 gives me -48. -2 times -48 gives me 96, which means I have a remainder of 0. This has to be 0 if I'm telling you this is a root. Now I'm not going to go and make this, x third, x squared, x and constant. I'm given a second 0, which means I'm going to do this process again with the other 0. I'm going to rewrite another one like this. I don't have to worry about this one. Nothing's going to happen here. I'm going to put my 0 of 3 right here, and I'm going to go through this process again. I'm going to bring down this 1. So 3 times 1 is 3. -3 plus 3 is 0. 3 times 0 is 0. 16 plus 0 is 16. 3 times 16 is 48, and I get a remainder of 0, which I better if I'm telling you that 3 is a root. Okay, now I'm going to take this out, so I know that this here, this is my constant, this is my x term, this is my x squared. So what do I have? I have 1x squared plus 16. So that's my other factor. So this factor I'm going to set to 0, and I'm going to figure out what the value of x is. If I tried to factor this doing the method that I've done before, which would be to make it x squared plus 0x plus 16, and then I try to find the factors of 16x squared that add to 0x, I'm going to find that this doesn't work. It's prime, which then the next step then would be, if that's prime, then I could use the quadratic formula, which is all this nonsense. I'm just going to write it out for review. Okay, so that there would be the quadratic formula. That's a lot of work. I would have to do this if I had 3 terms, but since I have 2, I'm going to do an easier way of doing this. So what I'm going to do is I'm going to solve for x. I only have x in one position, which means I'm going to subtract 16 from both sides of my equal sign. So then what do I get? I get x squared is equal to negative 16. Then I'm going to take the square root of both sides. So if I take the square root of x squared, that simply leaves me with x. So now I have to recognize that I have a negative under this radical. So that negative comes out as an I. And then that leaves me with the square root of 16. So when I simplify the square root of 16, I get x is equal, this is 4, and then this is I, 4i. But I have to remember that because I'm solving like from the quadratic equation, remember this plus or minus? Also remember that imaginaries come in pairs. So that means I not only have a positive 4i, but I have a negative 4i. So in this case, I have 4 roots. So these are my roots. My roots are x equals negative 2, which we got from the calculator, x equals 3, x equals 4i, and x equals negative 4i. So if I also were to ask you what are the factors, this becomes x plus 2, this becomes x minus 3. Now I don't have to multiply these out because I already have it right here. Right here. This gave me, let me highlight this in yellow, this is what I used to get these roots. So I simply need to write that down as a factor. X squared plus 16. So those are my factors. These are my roots of this very complicated looking quartic function.